that leads us into the most important question of what is the energy gap between chemicals and life? We're critiquing undirected macroevolution, and what we find here is that undirected macroevolution reverses the equation we just saw. It starts with dead chemicals. It adds what I call chance energy. Now, it's hard for me to pick a phrase here because this represents the random injection of all kinds of energy. You could have chemical energy, you could have energy by radiation. Heat is a form of radiation energy, so you're adding energy. You could have volcanoes blow up, which is more of a natural occurring big energy source. You add other stuff, and you wind up with cellular life. So again, the equation is you take dead chemicals, you add random chance energy, you add some other stuff, and you wind up with cellular life. The key point here is that that chance energy needs to be added carefully at the proper time. If we go with the hypothesis that there's a big pool of chemicals and those chemicals mingled enough so that at some point a cell was formed, well, energy can have a devastating effect. And it also needs to be at the right level. So there's a band of adding energy that works, and outside that band, it doesn't. You need to add enough energy to jumpstart the cell. Remember, there's additional energy needed to take dead chemicals and form cellular life. But that energy that's added needs to be small enough to avoid blowing up the cells into atoms. You could imagine, let's say there's a cell that's 99% formed. It needs 1% more in terms of the energy, and a volcano erupts and just blows it up, right? We've added energy with the volcano, but it was too much, and it blew up the whole thing. Not only does that energy need to be added within a careful band, it needs to be added simultaneously and independently, as we saw in Module 2, to create machines, to create machine factories, to create power plants, a data center, etc. So surgical isn't the right way to talk about this because it's so much more precise. And all of these items need to be created all at once and then wrapped within a chemical outer skin, right? The cell has a skin that encapsulates it. So adding this energy is quite precise, and I think it goes beyond our imagination, as we'll see. Now, our approach to looking at this is to use I call a scientific model, and it is a scientific model of this problem, to learn the probability of it happening. So probability is a way of measuring the likelihood of an event occurring. And that's what we're talking about here, is the first cell being formed. And we're going to use a scientific model to calculate this. But we're going to start with a very simple model under the most favorable conditions. So all of that other stuff we're going to ignore. We're just going to look at the chance energy. Because if we can conclude that dead chemicals plus chance energy cannot produce cellular life, and under the most favorable conditions, then it is impossible for the more complex real-world problem to be solved too. That's our approach.